In this section of the class, we'll be looking at derivatives and differential equation and trying to solve them using diagonalization of matrices. So let's start with a simple case. I'm going to think of derivative as a linear map from infinitely often differentiable function to that space again. So the first thing I want to do is just look at this specific function, e to the lambda x. I claim that it's an eigenvector for this. To prove that, all I have to do is apply d to f. I'll get the derivative of e to the lambda x. And I get lambda e to the lambda x, which is lambda f. So this is an eigenvector with eigenvalue lambda. In fact, if you look at the eigenspace of the value lambda, you'll get this vector as a generator, as a basis. So that means it's a line parallel to this. So the eigenspace so it's going to be all multiples. So let's take c e to the lambda x for c in R. Alright, so not only did we find one eigenvector, we found enough to generate the entire eigenspace. So all of this is in the language of linear algebra. Now let me rewrite exactly the same statement in the language of differential equation. So instead of thinking of a map and of eigenvalue, we'll think of an equation that includes this map, that includes derivatives in it. So the general solution to the differential equation y prime equals a y. So again, this is just dy and this is y again. So this means I have an eigenvector with lambda equals a. So this, the general solution is y equals c e to the a x. All right, so this statement here, this proposition, it's saying exactly the same thing as part B here, right? The solutions for this look like this, or the eigenspace look like this. Same question, just different language. All right, so in this class, we'll start with this fact. And our goal is going to be to solve not just one differential equation like this, but an entire system of it. Solve the linear differential system. So you'll have a bunch of functions, so y1, y2, yn prime. So all of those derivatives need to be related to the original functions, but we'll combine them. So a11 y1 plus a12 y2 plus a1n yn, and so on. a21 y1 plus a22 y2 plus blah blah blah. in this case, all the AI's are just numbers. So when you look at this, you can see the differential, so the differential equation, but you can also see the linear algebra, because if I look at the Aij, that really gives me a matrix. So the question is, how are we going to use all of our knowledge of matrices to solve differential equation like this?